Welcome to video 3B in the FMCP series. In this video, we will manually configure the servo drives used to control an EXCT kinematic, also known as the T-Gantry. This kinematic is unique in that it uses two motors to control one belt drive to get movement in the Y and Z coordinate system. The T-Gantry is also known for its high acceleration and deceleration capabilities and low cycle times in a pick-and-place application. The prerequisites for this step are the pre-installed Festo Automation Suite software version 2.7.0.752 and the CMMT AS plugin version 2.7.1.6. In addition, you will need all servo drives to have a preloaded firmware of version 32.0.9.9. Let's open the Festo Automation Suite software. Click on the device scan to display the connected drives. Now let's add the drives to the Festo Automation Suite project. Click on the Home icon and then click the magnifying glass icon near the device catalog. This will scan the drives available to add to the project. Highlight the servo drive that has the IP address connected to the motor on the left-hand side of the EXCT kinematic and click the Add Device button. Click the OK button to finalize adding the servo drive to the project. To change the name of the servo drive, click on the type number on the bottom of the recently added device and type the new name. In this example, we will use M1 for motor 1. Now double-click on the device to open the plugin. Each EXCT kinematic requires multiple hardware components to operate. 2 motors, 2 axial kits, and 2 servo drives with cables are required to control the EXCT T-Gantry. The example components on the screen are specifically for the EXCT size 15. You will need these part numbers to manually configure the EXCT servo drive. Click the Start First Setup button to start the wizard that will guide you through setting up the servo drive configuration file. Hover over the motor icon and click on the plus sign to enter the motor type. The EXCT15T gantry uses the CMMT AS80 MLS RMB motor. Enter the type number in the search field. Click to highlight the corresponding motor type and click the Apply button. Next, hover over the axis icon and click on the plus button. Choose a user-defined linear axis from the list. Since we are configuring EXCT15, we need to check the Unlimited Axis checkbox and use 90 mm per revolution for the feed constant. Now click Apply. Next, hover over the mounting kit icon and click on the plus button. Choose the user-defined mounting kit. The coupling used on each size of the EXCT has a specific mass moment of inertia value as listed. We will need to enter this value in the plugin to get the correct closed loop settings for the EXCT. For the EXCT15, enter the value 0.000039 for the mass moment of inertia and click Apply. This completes entering the physical EXCT15 hardware into the plugin. Now click the Next button to continue. On the device settings page, we will keep the activation via I/O and field bus. This requires that we have a hardwired 24-volt DC input to the X1A.6 input on the top of the CMMT AS servo drive. Now, let's adjust the mains voltage to the voltage we have available to power the drive. We will leave the default settings for the external braking resistor and DC link. Now, click the Next button. On the field bus setting page, we need to change the real-time Ethernet configuration to EtherCAT since the CPX ECEC is an EtherCAT master. Now, click on the Next button to continue. On the application data page, we will need to set the access mass that the EXCT is carrying. In the chart below, you will see the maximum capabilities of each size of EXCT kinematic. For the EXCT15, let's enter 3.5 kilograms. We will leave the load compensation and mounting position to their default settings. Now, let's click the Next button to continue. On the hardware switches page, we will keep the default settings since we are not using any hardware switches. Now, click the Next button to continue to the next page. On the homing method page, we will keep the default setting of actual position for the homing method. It is possible to use negative block homing in most cases at low homing velocities. Next, we will deselect the Move to Axis 0 point after homing and keep the rest of the setting at their defaults. Now, we can click the Next button to continue. On the Software Limits page, we will set the axis 0 point offset to 0 millimeters, and we need to make sure the software limits are turned off. Click the Finish button to complete the configuration wizard. Now we need to adjust a few more parameters within our M1 servo drive. Let's expand the Axis 1 menu on the Parameter Pages section and open the Axis page. On this page, we may need to change the reversing direction of motion based on how the motors are mounted to the EXCT kinematics. If the motors are mounted to the front of the EXCT, then we will need to reverse the direction of motion by clicking on the active checkbox. Now, we need to adjust stop deceleration parameter to 50 meters per second squared. This will allow the mechanics of the EXCT to stop faster in the case of an emergency stop. Now let's click Close Loop in the tree on the left to open the page. Notice the application mass that was set when stepping through the wizard. Now, let's click on the diagram view and make sure we are on the position control page. Based on the size of the EXCT kinematic, we will need to set some specific closed-loop control settings. From the position control chart, we will need to change the position control gain and maximum correction velocity. For the EXCT15, we will need to set the position control gain to 35 and the maximum correction velocity limits to positive and negative 0.04174 meters per second. Now let's click on the Velocity Control to open the Velocity Control Closed Loop Settings page. From the Velocity Control chart, we will need to make changes to the Velocity Controller Amplification Gain, the Integral Time, and the Velocity Filter Time constant. For Velocity Control Closed Loop Settings on the EXCT15, we need to enter 0.20 for the Velocity Controller Amplification Gain. Next, we will enter 0.00394 for the integral time. Finally, we will enter 0.0005 seconds for the velocity filter time constant. We don't want to recalculate the close parameters at this point, so click the No button. Now, let's click on Current Control to open the Current Control Closed Loop Setting page. From the Current Control chart, we will need to make changes to the amplification gain current controller and the integral time. For the current control closed loop settings on the EXCT15, we need to enter 17.81432 for the amplification gain current controller field and .002203065 seconds to the integral time field. Now let's open the configuration page under the Field Bus section and verify that the real-time Ethernet configuration is set to EtherCAT. Notice that the current actual Field Bus configuration is set to Profinet. Once we download the configuration file to the servo drive and reboot the servo drive, we will recheck and make sure the actual value is set to EtherCAT. Finally, let's open the CIA 402 page under the Profile section and make sure the factor group settings are -6 for position, -3 for velocity, -3 for acceleration, and -3 for jerk. Now let's save the configuration file. Let's click on the 3 bars at the upper left of the page, click Save As, give the project file a name, and click the Save button. Now, let's download the configuration file to the servo drive. Click the IP address link located near the Connect button. Click on the servo drive that is connected to the M1 motor and click the Apply button. Now, click the Connect button to connect to the servo drive and download the configuration file. Click the Write to Device button to continue. Let's hover over the red X to check the error. The error parameter set not found just means the servo drive did not have a configuration file already loaded. Click the Acknowledge button to continue. Now let's restart the drive. Click on Restart Device and then click on Store and Restart. You may get the connection not established message, and that just means the servo drive requires a little more time to reboot. Click the OK button and wait a few minutes before clicking on the Connect button to re-establish a connection to the servo drive. After a connection has been re-established, hover over the red X to see the error. The error motor change detected, 0-point offset invalid, just means the drive need to be referenced. Click the Acknowledge button to confirm. Now let's double check that the actual real-time Ethernet configuration is set to EtherCAT. Congratulations! You have just completed configuring the M1 servo drive. You will need to duplicate creating a second configuration file for the M2 servo drive. Then you will need to download the file to complete the configuration for the EXCT kinematic.